Right, so here's a talk through of every question which came up in the pre-course algebra test. So if you struggled on any one of these, watch this through and then have a go at some of the other practice questions which have been put online ready for your retest. Okay, so first of all, we are rearranging to make A the subject. First thing to consider is BIDMAS, brackets, indices, division, multiplication, addition and subtraction. When we're rearranging, we're thinking about doing this in reverse. We're thinking about keeping the A still and going up the chain, moving things away from the A bit by bit. So there's some addition involved there, so we are going to subtract the U from both sides. So now we're going to have V minus U equals AT. Moving up the chain, the A is multiplied by the T, so now we can divide by T doing the opposite operation. Opposite of multiplying is dividing. So we're going to have V minus U over T is equal to A. Right, question 2. We're given a formula, we're subbing in values and we're looking to find the value of S. Again, we're going to make sure that we are using BIDMAS in reverse when we are trying to rearrange and find the value of S. But first we'll put the numbers in. So we know that V squared is going to be 5 squared, U squared is 0 squared, plus 2 lots of minus 3 times by S. Before we move anything, we're going to simplify. So 5 squared is 25, 0 squared is nothing, and over here we've got minus 6S. The S is being multiplied, so we're going to do the opposite and divide. So we're going to divide both sides by negative 6, making sure that we're taking care of that negative sign. So we're going to have 25 over negative 6 is equal to S. And you can either leave that in fractional form or you could convert that to minus 4.17 correct to 3 significant figures. We've got no units in the question, so in this case we're not expecting units in our answer. Question 3. Right, we've got an equation here. It's got t and a t squared in it. As soon as we're noticing that t squared, we should be starting to think it's a quadratic equation. So, when we solve a quadratic, we need to have all the terms on one side with 0 on the other. And I prefer to have my t squared positive. So, I've got minus 4.9 t squared, so I'm going to add that, bringing it to the left-hand side. I want to bring 19t to the left, so therefore I've got to subtract it. And the 15 is positive and it's already on the left. It doesn't look as if it's something that I can easily factorise here, so I'm expecting to have to use the quadratic formula, which is t equals minus b plus or minus the square root of b squared minus 4ac all over 2a, and that's a formula you'll need to remember by heart for A level. So looking at the equation above, because I've got it in the form that I'm expecting, which is a t squared Right, so here we've got our values substituted in. We're just looking to simplify and then calculate. So if we first of all start by rewriting this out, we're going to be able to really clearly think about what steps we're doing in what order. Now, in terms of simplifying, not solving, we're going to be using BIDMAS in its standard order. So thinking about what operations have to come first. So there's no brackets, no indices, no division, so the first thing I'm going to have to deal with is the multiplication. So I'm going to select each of the chunks that deal with multiplication. Calculating that, we've got 2.4 in that section, then we've got 0.6, then we've got 0.4v, and then we've got 0.9. Looking over at that right hand side, we can't combine a term in v and a number, so we're going to have to move that 0.9 across. But before we do that, it would be worth simplifying the left-hand side. So 2.4 minus 0.6 is going to give us 1.8. Then we can subtract our 0.9 from both sides, so we'll end up with 0.9 equals 0.4v. And finally, we can divide both sides by 0.4. Again, I'm making sure that I'm doing the same operation on both sides. This will cancel, which will give v being equal to 9 over 4. Therefore v is 2.25. Okay, we've got three equations here, and we've got three things that we don't know the value of. So we're thinking about simultaneous equations. We're asked to find the value of a, so we've got to think about how can we substitute some of these equations into each other to get rid of some of the variables. First thing that would be useful to do is to substitute in this for f into equation 2. So just to make it nice and clear, equation 1, equation 2 and equation 3. So first of all I'm going to sub 3 into 2. So now I've got ma equals m sine 30 minus 0.4r. I've still got far too many variables in this. I've got m, I've got a, and I've got r. So the next thing I'm going to do is to sub 1 into equation 4, which I've just created above. So once I've done that, I'm replacing r with m cos 30. So I'm going to have ma equals m sine 30 minus 0.4 m cos 30. Still got two variables, I've still got m and a. But if I look closely, I've got an m in every single term. So, knowing that I have to do the same thing everywhere, I can divide every term by m. So the m will cancel here, here, and here, greatly simplifying our equation. So we're going to have a is equal to sine 30 minus 0.4 cos 30. And then, as we should have a calculator, we can substitute those values in, and that will give us a final acceleration value, or a value, of 0.154. Okay, so we've got two equations here, and we've got more than one variable, so again we're thinking simultaneous equations. Start off by numbering them, equation 1 and equation 2. And because I'm trying to find p, I'm going to be looking to substitute in the other letter which we're not sure about, which is r, so I'm just going to be left with an equation in terms of p. The easiest equation to rearrange in terms of r, I would say, is the top equation, as it's just got r by itself. So equation 1 rearranged is just going to give us r equals p sine alpha plus 2g cos alpha. So then we can do, if we call that equation 1b, because it's just a rearranged version, we can do sub 1b into 2. So we're going to have p cos alpha minus 2g sine alpha minus, we're given that the value of mu is 0.1. So 0.1 brackets, subbing in that 1b, p sine alpha plus 2g cos alpha. And that's all equal to 0. If we're trying to make p the subject, we're going to need to collect together all the terms involving p and move to the other side all the terms not involving p. So terms involving p are going to be the two underlined in red, this term and this term. So p cos alpha, and our second term is got from multiplying here, so we're going to have minus 0.1 p sine alpha. Our other two terms are here and here. That one gained from multiplying these two terms together, and we're going to move them straight to the other side. So thinking about changing the sign, it's going to become a positive, and 0.1 times 2 is going to give us 0.2 g cos alpha. Now looking at this equation, we've still got two variables here. We've still got p and g, but we're told in the question that we can leave it in terms of g, so that's not a problem there at all. To get just one p, because at the moment we've got two, there's two possible options. Either you can start substituting in the values for cos alpha and sine alpha now, and then you can count up how many p's you've got in total, or you can do some factorising, which is the technique that you'd use if you were less sure about the values of sine alpha and cos alpha. So factorising out the p, we can have cos alpha minus 0.1 sine alpha. And as we're going to leave it in terms of g, it's going to be useful to bring out that factor of g now. So 2 sine alpha plus 0.2 cos alpha. We've very nearly got the p by itself. To do that, we've got to divide by everything in the large bracket. So p is going to be equal to g lots of 2 sine alpha plus 0.2 cos alpha. And we're going to divide all of that by that large bracket cos alpha minus 0.1 sine alpha. Now at some point we've definitely got to sub those values in, and now would be a good time. So putting all of that into our calculator and leaving g out, we're going to end up with 1.08g once we've rounded to 3 significant figures.